lot of questions, other than ones that I'm going to kind of talk about when we're going to work. I was going to work problem number 1 from the more practice trusses that I sent out. And so I'll kind of answer some questions people had from that. But I don't have any other kind of just out there general questions. I was telling Adam we have folks, several folks in 1-3. We've got some folks in, somebody in Unit 3, but they skipped Chapter 2, and then we've got some folks who are getting into 1. So and that's kind of where I'm at also, is my kids are testing. My kids took the test through Unit 2-1 last week, and it's on their final also. Any questions out there for the greater good that you'd like us to talk about tonight? No?
I had asked you, this is Jennifer, and I had asked you about some review materials because my students will be taking their semester exam in the first week of January when we return from Christmas.
Did you find my stuff online?
I did. I think I need a little help moving through it because I didn't find one document. I'm assuming that there were several documents.
One big document. It's like, yeah, it's just one big document from last Wednesday.
I didn't see that. Okay, I need to go back and look again then. I apologize.
Yeah, that's okay. It's on last Wednesday, and it's the it's the final exam review.
Okay.
If you can't find it, let me know.
And I'm going to look now.
Look again.
Because I did look, but there were some things you clicked on and it didn't say view, and it opened up, and then there was nothing there, and then there were other things. So I'll go back and look again. I apologize.
No, that may be, and maybe you're just not finding it because it's just a little hidden. So let me know if you can't find it. I think it was last Wednesday that I attached it, and if you can't find it, then I'm kind of busy until 10 o'clock, but I'll attach it tonight at some point, or maybe if Adam's talking, maybe I'll get in there and attach it. But
and Karen, is that on your school website?
It is, or should be. I'm talking about it now. I'm starting to really doubt myself, but yeah, it should be. So I may, when I finish this trust, I may turn it over to Adam, and then I may go check and make sure, and I'll let you guys all know. And that's just that's my school district's, well, that's the review I wrote, and so that is the one we use in my school district. So if you could be conscientious about posting that only to a site that's password protected, so it's not out there for the general public, I'd appreciate it. And it is what I've deemed that I want to test in my first semester. So it is not a Project Lead the Way document, it's just written by me.
Does that, when you say first semester, is that like you're on a whole school year?
Yeah. So it goes through Unit 2-1.
Okay.
So it's all of Unit 1, 1, 2, 3, and 4, and 2-1.
Okay. We will be testing on units, all of Unit 1, all of Unit 2, Unit 3, and 4.
Mm. Yeah, so you need the
semester. We're on a semester basis.
Yes. So are you not just using the end of course exam?
Yes, ma'am. But
oh,
maybe I'm confused because.
Yeah, I only have, what's out there for my kids is only a semester.
Okay. The high school that I'm at, I have to cover all 4 units.
So no, I don't have, so that's what's out there is my kids take a full year. So what's out there would only get you through Unit 2-1.
Yes, ma'am. Thank you. I'll take anything.
Yeah, sorry.
Thank you.
Amy, it's my website, and I'll get you, it's just my school website, and I'll get you that, I'll email you that address later tonight. Okay. Okay. Any other greater goods? Okay. I am going to have Adam turn it over to my screen, and I'm going to put the SMART document back up. And I'm just going to work through the first trust that that I sent out of the 4. It was in both the first and the second document. And I just made these up in MD Solids. So there's really no magic to that. That's the joy of MD Solids, is you can, kids can be like, can I have more? You can just create them, produce them, and then I always click compute for myself so I have an answer to it. So it's just a nice avenue for lots and lots of practice. So,
all right.
Okay.
On my end, it has frozen.
Huh.
Wait, maybe I got it back. There we go.
Oh.
Okay.
Okay. Okay. Just a second, we'll pull up. If you guys have that, one of the things that MD Solids doesn't do is necessarily, it doesn't put letters on them. So I've made an agreement with my students that if it's not lettered, letter it from the top left corner and go clockwise in the naming of that. And so on number 1, just a second, my smart board's coming to life. Sorry, top of the hour, all of our electronics shut down. So this point right here, I would name A. This joint right here, I would name B. And this joint right here, I would name C. And so just again, by default, if it doesn't have any letters on it, I tell my kids, start in the top left corner, go clockwise, and name each joint as you travel around. And it kind of helps me when I forget to fix this up. So I'm going to kind of talk through my steps again. So step 0 for my kids is to mark on the problem itself all of the potential reaction forces. So A has 2 potential reaction forces because it is a pin. So we always make the assumption that those reaction forces are going in a positive direction. So I'm going to assume that the reaction force up, which I've named RA in the Y direction, and reaction force go right, which I've named RA in the X direction, are as stated on the graph. And then I have a roller, and I have a few kids that are still struggling with how many, well, not how many reaction forces. They all know that there's one, but they struggle with which one it is. So we have trash cans in our cafeteria that have wheels on the bottom. They're just like a little cart they sit on. And so I grabbed like 3 of those from the cafeteria and had kids sit on those and told them they were not allowed to touch the ground with any body part, but they had to react to me pushing it. And the fact is they can't react to me pushing it, and that's because this left-right rolling, they can't stop. But it can react to keeping them off the floor. So I'm going to have reaction force C in the Y direction as the only other reaction force at joint C. I call that step 0. That's where my kids mark that on their the given problem. Then we're going to go to step, well, probably I'll go ahead now and put into play the what I call my summary truss. And it's going to have all the information about A, all the information about B, all the information about C, and then all of the members in there. And right now the only thing we know for sure is that there are 25 pounds of applied force at B going down. So I have the angles marked on here because when you do MD Solids, it's got this nice little grid, but that grid doesn't copy well. So you'll notice on that document that I sent you this week, the first one, that I had to put some measurements on because the grid doesn't copy well. But if they have the angles up here, then they don't really need those distances. They can calculate those distances. But I'm going to go ahead and tell you what was in that original problem. And that is the distance from A to B is 5. So the distance from A to B is 5 feet. The distance, the vertical distance from height B down to C is 3 feet. And then another piece we're going to need to know, and that is the horizontal distance between A and C is 2 feet. And so just FYI, if you make one in MD Solids, that grid doesn't copy very well, so you'll need to mark that in. So this is the information that you had on the one that I sent you. So let's go ahead and do what I call step 1. Step 1 for my kids is always to sum the moment. So we know any clockwise turning force is countered by a counterclockwise turning force. And so when we sum all of the moments from all the external forces, we should not be turning at all. It should be 0. So we have to make a decision where it is that we are going to anchor or hold our truss for this moment. I'm going to choose to hold at the pin. Okay, it's got a lot of stuff going on. I think I can really clean up some information that I want to know if I hold there. So what I have my kids do is go ahead and acknowledge a couple of things. One, that moment is force times perpendicular distance, and that we are going to take the moment from A plus the moment from B plus the moment from C, and those are all going to add up to be 0. So I'm going to go ahead and put my finger on A, and I have the kids with their paper put their finger on A, and I say, now if you push up at A or you push the right at A, does it turn your paper? And the answer is no. And you say, well, why doesn't it turn your paper? Because there's supposed to be a moment. And they come up with the fact that those forces are 0 feet from the finger. So that is force times distance of 0. It's going to be no turning force because that's where my finger was. That's where I'm holding it. So now I go to joint B. And so I look at what external force I have there. So I'm holding at A. So I'm going to hold right here. I'm going to put my finger on B and rotate my paper. And as I rotate my paper with that force that comes down, it will turn my paper clockwise. Clockwise, we know, is a negative moment. So it's negative. This is a 25-pound force. So it's an up-down force. So I'm looking for a left-right distance. It is 5 feet horizontally to where I'm holding it. So 5 feet. Plus, I'm going to do the same thing at C. Remember, I'm holding at A. I'm holding right here. I take and I push my paper up right here, and that's going to rotate that truss counterclockwise. Counterclockwise is a positive moment, so I'm going to keep just my plus, not put a negative in there. The name of my force, it doesn't have a number, is RCY, that vector. And it is an up-down force which has a left-right distance to A of 2 feet. I know that that's going to be equal to 0. So I calculate that out. I'm going to get negative 125 plus RCY times, or negative 125 foot-pounds times plus RCY times 2 feet. It turns out that RCY times 2 feet is going to equal 125 foot-pounds. And divide both sides by 2 feet. I'm going to get that RCY is going to equal 65.5 pounds. And I noticed that that was a, 62.5, sorry, 62.5 pounds. Notice that that's a positive number. That means that the assumption we made about RCY going up was true. If it had been a negative, we would take the opposite of that direction. So I'm going to go up to my summary truss. I'm going to say, oh, I have a reaction force of 62.5 pounds. I know it goes up, so I'm going to go ahead and draw that in. Okay, so that is everything that I'm going to do for step 1, because at this point, I only have one unknown left-right force and one unknown up-down force, which means that I can now sum the forces and come up with my unknowns. Now, I have my kids box their work so that I can tell where that next step starts. So my step 2 is always to sum the forces in the x direction and to sum the forces in the y direction. We know that it's not falling or flying, shifting left to right, that those have to be equal to 0 to be in static equilibrium. So I'm going to go ahead and go, I did x's first, and take all my left-right forces. So the only left-right external force I have is RAX. So I know that RAX has to be equal to 0. Now this happens a lot. The second one that I gave you on this more trust problems, I kind of like it because I have a left-right force on it, so RAX isn't 0. I kind of like that. Now let's go to summing the forces in the y direction. What I know at A at this point is that I have a go-up force called RAY. Let's go up, so I'm going to make it positive. At B, I have a go-down force, so negative 25 pounds. At C, I have that force I just found, and it's a go-up force, so it's going to be positive, 62.5 pounds, and that all needs to be equal to 0. So when all is said and done, I'm going to find out that RA in the y direction, combine those and then subtract, is going to end up to be negative 37.5 pounds. Is not true. It now needs to be a down vector. So I'm going to go to my summary truss. I know that I have go down A of 37.5 pounds. And I'm not even going to mark RAX. One, I'm kind of low on space. And if I did it, I would just put a segment with no arrow on it and put 0 if I was going to do anything. So I now have all of my external forces documented. So now I need to make a decision. And this part, except for the fact that it's really super hard for my kids to consistently find moment correctly, this part, they are pretty good at knowing step 0 is putting the reaction forces on our problem. Step 1 is attempting to find the moment. Step 2 is attempting to sum the external forces. It's always at this point where they want a solid recipe, like, should I always start at joint A? And the answer to the question is you should start at the joint that has the most information and the least amount of work. So for us, joint A has a go-down force, it has a horizontal member and a diagonal member. That is the exact same situation with B. So we could choose either of those at an equivalent difficulty. They are both easier than C because C has 2 diagonal vectors to it, 2 diagonal members. So that's going to be more complicated. And we actually don't know enough at this point to find C. So A or B, either of them is fine. I'm going to go ahead and choose A. It doesn't matter. It's why I ask my kids to number their work so I can tell which one they chose first. So what we currently know about A is that we have a go-down reaction force of 37.5 pounds. That is the only for sure force we know at A. I do know that the member from A to B could push or pull on joint A. So I need to mark that in. I also know that the method that we use, the method of joints, asks us to assume that all of our members are in tension until we prove otherwise. So if they're in tension, then the member itself is pulling in, which puts its force away from the joint. So this guy is, I call it AB. That's its endpoints. And it's a go right member. And then we have the diagonal. And I'm going to draw it in tension, so it goes away from the joint. And AC, anytime I draw a diagonal vector, I need to draw the up-down component, and I need to draw the left-right component. I'm going to name those ACX and ACY. So only other thing that I know about this picture is an angle that was found clear up here. At angle A, the angle between the horizontal and the diagonal is 56.31 degrees. And that, folks, is that angle right there, which is not inside the triangle that I've drawn. So I do know from alternate interior angles that this angle right here is the alternate interior of that red dot I placed. So it's the exact same size. The other thing you can do is talk about the fact that the red dot that I placed and that one right there, the red-black angle, they're complementary. That would be 90 take away the 56.31, which would give you that red-black angle. But I like to use the alternate interior, just for nothing else, so kids know there's a reason that they use geometry. So this is everything we know about this graph, or this joint. So now I'm going to do the same thing I always do. I'm going to sum forces and see what I know. The only piece of information that I for sure know besides the angle is an up-down piece. So I'm going to go ahead and sum the forces in the y direction. So everything that's up or down, I'm going to document. I have a go down of 37.5 pounds. So anytime it is a go down, I'm going to put a negative. Plus, I have another go down, which doesn't have a number, it just has a name, AC in the y direction. I don't have any other up-down forces, so those are the two that have to sum to be 0. So if I isolate ACY, it's going to turn out that negative 37.5 pounds is equal to AC in the y direction, which means that that should not be a go down vector, it should be a go up, which means that that vector AC, that member, was not in tension, it's really in compression. But throughout this entire joint, we're going to work with the fact that we have decided that this is negative 37.5 pounds. We're not going to change the orientation of the arrows. We're going to know that it's backwards because we're going to keep the negative on it. Once we go up to the summary truss, we'll make all of our changes, put a positive magnitude, and change the direction of the member that we're working with. So that's all the information I have that's clearly, easily stated, summing forces. So now I'm going to use some right triangle trig. So I look at this little triangle that is the red, blue, black triangle. It's a right triangle because the red go down and the blue go right are perpendicular. And I have the angle 56.31, and I know the opposite side. So based upon this angle, I know the opposite side is negative 37.5 pounds. I'm looking for the adjacent side. So I'm going to go to right triangle trig. The acronym we use for the trig ratios is SOHCAHTOA. The sine is equal to the opposite of the hypotenuse. The cosine is equal to the adjacent of the hypotenuse. The tangent is equal to the opposite over adjacent. So I have the opposite. I want the adjacent. That's going to be tangent that I'm going to work with. So I'm going to say the tangent of the angle that I know, which is 56.31 degrees, is equal to the length of the opposite, which we're working with that negative. We haven't changed that yet, over the length of the adjacent, which doesn't have a number, it just has a name. One thing you want to do, make sure you check, is that your kids' calculators are in degrees. I have some kids whose calculators are often set in radians because if their calculators get cleared, it resets it in radians. So we're going to make sure you're working in degrees. So what we're going to do to solve this, we'll multiply both sides by AC in the x direction, and then we'll ultimately divide both sides with a tangent 56.31. So AC in the x direction is going to be negative 37.5 pounds over the tangent of 56.31 degrees. And when you crunch that out, it turns out that ACX is negative 25 pounds. It's good news that that's negative, because if the go down was wrong, then the go right has to be wrong. So that's a nice check. You know that this is also in the wrong direction. So again, that is not in tension, that's in compression. So now we have the ability to find all of our missing pieces. We have the ability to sum the forces in the x direction, get AB. We have the ability to find AC with some more trig. I'm going to go ahead and do that piece where I find AC with some more trig. Excuse me, let me get some more board. So I'm going to go ahead and use this opposite piece again, and now I want to get my hypotenuse. So opposite and hypotenuse is sine. So I'm going to take the sine of the angle, 56.31 degrees, is equal to the length of the opposite, negative 37.5 pounds, over the length of the hypotenuse, which just has the name AC. Again, I'm going to multiply both sides by AC. Divide both sides with a sine of 56.31. AC is equal to negative 37.5 pounds over the sine of 56.31 degrees. So it turns out that AC is negative 45.06 pounds, and we know that that should really be in compression. It's negative, it's going the wrong way. So when we go up to our summary truss, we're going to fix that. One more to find. Let's go ahead and find sum the forces in the x direction. So I'm going to sum the forces in the x direction. That has to be equal to 0. I have a go right, this one, I have a go right that is negative 25 pounds. Here's the weird part. If that was a go left and it was negative 25 pounds, I would take the opposite of negative 25. So remember that we use left is always negative, down is always negative. So it just means the opposite side. The negatives are things that really confuse the kids on this, or would confuse me when I started doing this as well. So we have a go right of negative 25 pounds, and we have a go right of AB. Those are equal to 0. So it turns out the vector AB is 25 pounds. So this one is in tension because it's correct, it's positive. So that was the correct way to draw that. So let's go up to our summary chart here. Okay, to my summary chart, let's see what I've got. I've got AB that was correctly drawn in tension. Okay. Remember, it's being pulled out, so its reaction is to pull in. We said that that was 25 pounds. I always have my kids put a letter to show that they know what that means. And then that A to C, that is not in tension, that's in compression, so it's being squeezed, so it's pushing out, and that was 45 point, I think I said 06 pounds, and that one's in compression. Make sure that's what I put. Yeah, 45.06 pounds, and that's in compression. So notice that this is going towards the letter as opposed to away from the joint. So we now have one more member that we need, and we never have to do all of the joints. We can always have one left over. So I'm going to choose to do B. Remember, it was the other easy one. We have one diagonal to it. So I'm going to get a free body diagram. This is step 4. So here we have B. So what I know about B so far, I know that I have this applied force of 25 pounds. I know that I have a go left from the member I just found, that AB, of 25 pounds. So those are both marked now. And then I have a diagonal, which I'm going to draw in tension. So that's going to go away, and that guy's name is BC. As soon as I draw a diagonal vector, I need to draw its components. So this go down will be BC in the y direction, and this go left is BC in the x direction. I now have everything that I know about this marked on it. So let's go ahead and do the same thing we always do, sum the forces in the x, sum the forces in the y. And the fact is I have a lot of information this time. Summing the forces in the x direction, I have a go left 25 pounds, so negative 25 pounds, plus a go left called BCX, so that's negative BCX. Those add up to be 0. Those are my only left right, so it turns out that BCX is equal to negative 25 pounds. That tells me that BC is not really in tension, it's in compression. So I should get negatives on everything else I work with BC. So this is now negative 25 pounds. That really should be a go right. So now I'm going to sum my forces in the y direction are equal to 0. I've got a go down 25 pounds. Plus I've got a go down BC in the y direction. Those are all my up-down forces. That equals 0. So I get negative 25 pounds for BCY as well. So we're hoping it would be negative, but another thing I want you to notice is this guy clear up here said that this angle right here was 45, which means this angle right here is 45. And we love 45, 45, 90 triangles because they have legs that are the same length. They're isosceles triangles. So the kids start to notice that those come up a lot. If you want to save some time on a truss, you can do that for kids. So it ends up that those are both negative, so we know that BC should be in compression, and it's the only piece that's left standing. Now I use the other triangle instead of I used trig to find the hypotenuse. This time I could use this 45 degrees, and I could use sine or cosine. I could use special right triangles where the leg times the square root of 2 on a 45, 45, 90 is equal to the hypotenuse, or I could use Pythagorean theorem. Doesn't matter which one I use here. Any of them will work. I'm going to go ahead and do the sine. 45 degrees is equal to the length of the opposite over the length of the hypotenuse. I'm going to figure out that BC is equal to negative 25 pounds divided by the sine of 45 degrees. I'm going to get that BC is equal to negative 35.36 pounds. And that is the last piece that I have standing on this. So we're going to come up here. This is not in tension. It's in compression. It's being squeezed, so it's reacting by pushing out. It's in compression. We said it was 35.36 pounds. So that's the summary truss. I just did this. I just did my 2-1 test last week, which means that I had a lot of grading to do. I did on a quiz where I asked them for an entire truss that had 3 members, but on the test, it was a 5-member truss, and I only asked them for like 3 of the members, so they didn't have to do all of it. They did have to do reaction forces and then 3 members. So, questions for the greater good? I know that's a lot. Adam, you may have been answering some of those while I was working.
Yeah, there's only 1 or 2. No.
Okay.
Nothing too big.
Okay.
So what's nice is we've been recording this whole thing, so we'll post this tomorrow on the LMS like we have been. So if you want to go back through and watch, Karen go through this, gives you something else to use as a resource.
Okay. Questions for me? One of the things that Amy did today was she sent me a truss problem that she'd worked out. She said, stuff's not looking right. Can you just find out kind of where I went awry? And I just went through, found out where some issues were, and sent it back to her. So if that's something that you find yourself getting stuck in, then you can always just send a picture of that. And then the one other question that I have that's kind of related to trusses was, what do you do when your kids mathematically aren't set for this event? And so mathematically that means that they know right triangle trig. It means that they can do equations. Now, this equation-wise is not nearly as difficult as the truss calculations. Those formulas are much more complicated. The heat transfer or energy transfer, those are much harder. The real key to this will be that they understand right triangle trig. And the 1 year I taught this class to kids who hadn't already had geometry, I spent 3 days on right triangle trig, and it was the best investment I could have made because they can't do it without. So if you can teach them how to use inverses to find angles and how to use sine, cosine, and tangent to find with an angle and a side, find the other side, you're better off. There's some really good Khan Academy stuff on right triangle trig. The right triangle trig is out there everywhere. So if you want your kids to work through it, maybe as homework, where they, go watch some videos and do some worksheets, that would maybe be some time you could spend outside of class. The first year I taught, I reference my physics teacher all the time because I teach math all day and I teach physics a little bit. So, I had physics teachers who taught me, and then I went and taught that. So chat with your math teachers if you need somebody to help you with a SOHCAHTOA sine, cosine, tangent lesson. Another question that was asked was about the scanner that Project Lead the Way wants you to have. I have a scanner in my room, but my kids all use CamScan. The line at my scanner was not worth my time. So all my kids have phones now, or at least every partnership has a phone now. And so CamScan is free, and my kids just use their camera, and it's shockingly great. Adam, what do you do with your stuff? Do you have a scanner, or do the kids use scan apps?
We mostly use the scan apps on the phones. The documents I have them fill out already digitally, but if it comes down to like engineering notebook or something like that, and they want to submit it for their portfolio, they just take pictures of it and then, upload it to their own files or whatever.
Mm-hmm.
Yeah, scanners is going to be way too slow, and they all have a phone on them, so might as well use that.
Yeah, use it for good.
Yeah.
I have a question.
Mm-hmm.
So my school, this is the first year that we'll be teaching the POE. Can you tell me what you would suggest as having like a prerequisite? Like, do you think that they should have the IOE before having this?
Go ahead. My kids don't have to have IED. I wish they did.
Okay. Yeah.
But about half my kids have IED, half don't. I get a lot of upperclassmen, so I would hate to lose kids at the sake of them not getting to it, because they can kind of squeeze one class in. Mathematically speaking, the best move I made was to make geometry a prereq.
Okay. What about Algebra 2?
Oh, they can be in Algebra 2.
Okay, in Algebra 2. Okay, thank you.
Yeah, we don't, like, our numbers at our school are fine, but they're not exactly so great that we can really limit the amount of students that can take each class. I think, definitely the math is more important than IED. It'd be nice if they had both, but the math will definitely help them out a lot. But I would say POE is the hardest math content course that Project Lead the Way offers in the engineering realm.
Okay. I'm going to let you take the screen over. I'm going to go check and see if my review is attached. And then I'll put it out. Last Wednesday is the date that I'll put it on if it's not there.
I had asked a question. Can you hear me?
Sure.
I am wondering if somebody has a picture of a truss breaker for the construction truss project. I do not have the elaborate truss tester piece of equipment, and so we were going to kind of make one and break it that way, and I didn't know if somebody had a picture of what that looked like, or a video of the trusses breaking. I saw several bridge projects that had a makeshift tester, but I guess with our little practically two-dimensional truss that we're making, I just don't have a good idea of how to that.
If you go to that unit, and Adam, help me on that unit, they have a VEX-built truss force breaker that, Adam, what unit is that? Is that in
2.1?
2.1?
Yeah, right at the end.
And they have actual directions on how to build one out of VEX.
Yeah, we use Fisher Tech, and it looks like they attach a motor to it, and I was going to use something a little bit lower tech than that.
Honestly, I would create a structure where you put the bridge in place, and then you put a force sensor on it and pull it till it breaks.
Okay.
Yeah.
The VEX truss is a lot of build for not a lot of bang, in my opinion. And so I would just, do you have the force sensors?
Well, I have a force sensor, but I guess just that whole statement, hey, put a force sensor on it and pull it until it bangs or it breaks. That's
Right.
So I don't know how to do that. Oh, no.
Well, the force sensor probably has a hook on it.
Yeah.
Is that true? Okay,
So I
put
have a veneer
hook over one of the joints. So put that hook over one of the joints. Have, you know, two kids or a kid hold the truss at where you want the supports to be, and then hook that force sensor to whatever joint. That's the VEX force sensor. And then just pull down, making sure that if it's an electronic force sensor, you'll be able to tell where all of a sudden that break happens, and then you'll know at what force on that joint that break occurred.
Okay. So, like, where would the truss go in this picture you're showing? So, where? Oh, okay. So you got the little spaghetti truss there.
Yeah.
So we just spent a whole, 30 minutes going over truss, the calculate. I know how to do that. We actually did that 2 weeks ago. I don't know how to build this thing, and actually, I don't have VEX. So,
No, you don't.
I don't know that it's worth the time.
If I have a picture of something, I can generally do something. But like that whole, okay, and here's the veneer force sensor, but like, how do you hook up the veneer force sensor to the compute? I mean, I don't know how to do that, and I don't actually know where to begin.
So this is the force sensor, right? Do you see the force? Do you see the force sensor in the picture?
Yeah, I do.
Okay, and so do you see how they have kind of a U that loops over the top of the truss? Adam's pointing to it right now.
Okay, so
and then
okay,
yeah, and so that just goes over the joint that you want it to be at.
Yeah.
And then this particular build, you roll that roller below and it pulls the string and slowly pulls the force sensor down. You could do that with your hands if you wanted to.
Yeah.
So you just put a string down there below.
The force sensor up to the computer.
Yes.
I guess I'm just like completely.
Yeah.
Sorry.
The actual force sensor.
I feel really stupid asking that, but I don't know how to do it.
That's all right. The actual vernier force sensor, you would hook up to one of those Go links, and then USB you plug into your computer, and you use Logger Pro, and it'll actually just pick up the force sensor. You don't have to do anything. It'll automatically load and see that that's plugged in, and then like when you pull or push on this hook down here, it's going to show you on Logger Pro, it's going to show you the force going up or down.
Okay, and then what's the maximum force? Because actually the sub ended up doing the little break it that we did, and they had a hard time getting enough force to break it.
The max force, there's two settings on it. The max force is 50 newtons if I remember
10
correctly. 10
newtons or 50 newtons.
Yeah, which is
10
like
or 50.
What, 13 pounds or something like that maybe?
What kind of glue did you use, Patricia?
Well, we just did, I was trying to break everything up. I think that was actually your suggestion. So I gave them popsicle sticks and straws, and, I gave them a variety of materials, and they just made a truss, and then they got to break it without really measuring any of the forces, just to kind of see where it broke, where it deflected, all of that kind of stuff. And then we used that to kind of hang on all of the concepts related to the free body diagrams, and then the kind of the centroids and the deflection, which we did this week. And so when we come back from Christmas, I'm going to have them do the actual constructed truss rather than, they use a bunch of silly materials to kind of also compare the properties and how they responded and their shapes. And so we'll do that constructed truss, but I had a devil of a time getting the truss to stand vertical. That was the other problem. But of course, we were using popsicle sticks and spaghetti, but getting it to remain in a vertical position while it was broken. And so I guess that picture, they kind of leaned it up against
some walls. Yeah.
Yeah, it's like there's two pieces of metal that it sits between. They actually, it took me a minute here because I don't use this as often. I use it in the summertime, but there's step-by-step instructions, not on just the build, but on actually how to test it.
I have the Fisher Tech as well, so that's,
Yeah, but the step-by-step of how to use it is probably what you need.
yeah.
Yeah, even if you're using the Fisher Tech, it's still the same as far as how Logger Pro gets set up. So you have to be a little bit more creative, but we've done this before when we got to a training in the summertime before we completely switched over to Vex. We used the Fisher Technic stuff in order to, jerry rig in order to make it work. It's a little bit more difficult.
I don't know. Maybe I'm really struggling with that. How to set that up and how to make that work. So.
Does your physics department use force sensors?
Actually, I borrowed their force sensor, but I don't want to ruin it by putting too big a weight on it.
I would just ask them how to use it.
Yeah, that's new. So it's brand. They've not actually even used it. So they lent it to me, not used it. So that's why and I'm new here, so I really don't want to borrow their new equipment and ruin it before.
You won't pull it. You won't pull it too far. 13, 15 pounds, that's a lot of pull for popsicle sticks, unless you're using like super great glue.
But my next thing, and so that was just kind of get them started, but when we come back from Christmas, we're going to do the constructed build. And that's just with balsa wood?
Correct, yeah.
And then so we buy sheets of balsa wood, or?
Just go to a hobby store and buy rods of it. Just like Hobby Lobby.
Yeah,
or Michael's.
They'll have sticks of it.
Okay.
And if you've already gone through the process of building a truss, students have built a truss out of popsicle sticks or whatever it might be. I don't know that doing 2-on-8 then with the balsa wood is needed. I think you've already done that process.
Right. That'd be a good way to save some time. I don't know that I would come back and do it.
We may have lost her.
Oh, I'm here. No,
okay.
Sorry.
So I don't know that I'd spend that time either. I kind of agree with Adam. I don't know if I'd spend my time that way. If you have some other stuff you want to do.
Truss calculation after truss calculation after truss calculation, and they hate that. I mean, they just
okay. Well, maybe it's time to move on to 2-2.
Okay.
Yeah, one of the hardest things that I have every year is, all of us, any POE teacher, no matter how good you are, the hardest thing that we do is the truss calcs. As far as student comprehension, and you're going to find it over the years that you teach. Some years you're going to have great students and they're just going to grab it and they're going to get it. And other years you tried your best, but you have to kind of move on, and you give them all sorts of resources that they can use to help study, but it's just you could spend months trying to get them to learn it, to really grasp it, but they're just going to end up hating the class, and that's not going to turn out to be a good thing in the end.
And I guess I'm kind of fighting that, and I am the third engineering teacher in 3 years, and when I started with, simple machines and going through all of that, I literally had a mutiny. I had people in the principal's office, this is a boring course, this is isn't what I signed up for, so much so that, the principal was just like, you got to find a way to make them not hate this, and that was never my intention. So I kind of, I liked Karen's idea of, I break it up, I build it as I go, but I don't know if I just go straight to the bridge project from here, because I'm just really sort of struggling. They really liked the building it and the breaking, and unfortunately I got laryngitis right in the middle of it, and then
one thing you could do with balsa wood if you wanted to not use force sensors is my kids do a pasta bridge competition at KU, and the way they break it is that they put a 2x4 across the bridge and hang a bucket on it, and they fill the bucket with sand.
Yeah.
And they fill it until it breaks, and then they weigh the bucket. And so that's what my kids will do instead of balsa wood, is they'll build it out of Elmer's glue and pasta. But that way you wouldn't have to use force sensors at all.
Yeah, and that actually,
and scale.
that was my strategy for the next one. But what I was
Yeah.
going to sneak in is when they did the trust, I was going to make them do the calculations just for their particular trust. Because, again, I like I said, I'm kind of sneaking the calculations, and I realized maybe that isn't what was intended. But I think maybe the first teacher 2 years ago was like not very heavy at all on the calculations, and then last year's teacher, she started late and she didn't have the curriculum until way later, and so she used a lot of projects, and so there was all kinds of different expectations of what this course is going to be, you know, mine, the principals, the students, and it's kind of this giant collision. So I'm trying to kind of be true and follow the curriculum, but I mean, my principal basically says, you know, the Project Lead the Way curriculum is boring. That's what she said to me. I mean, I'm like, you haven't had a teacher that went through the
That's too
training.
bad.
Yeah.
So I'm really kind of fighting that. So I did like the Spaghetti Bridge, and I'm going to move into that. But I do feel like I at least need to go through at least one set of trust. That was kind of what I told them. You owe me one set of calculations for all this stuff so that you at least know that they're there. And if you're so inclined, you can go back and do them. But and then we'll move on. And then when you do your Spaghetti Bridge, if you just want to go rogue, go rogue. And if you actually want to figure out where the weak spot is, then you figure out where the weak spot is. So that kind of meets everybody. But I was having trouble with that smaller trust, figuring out how we were going to break it.
Yeah.
So you, okay.
Yeah. Yeah. I have to go because my daughter is in a concert, so I'm going to let Adam take over. I did check my website, and it is my review that goes from the beginning of Unit 1 through 2.1 is on last Wednesday's date if you wanted to access that. So I will see you after the holidays. So again, email us with questions, and we'll just Adam and I will tag team, and whomever's best suited to answer it. We certainly we're not going away. We're just we're just not going to have a meeting for a little while. Okay. Okay. Thanks, guys. Thanks, Adam.
See you, Karen. All right. What I'd plan then, just for the last little bit of here, is to start to get into 2.2, which is the materials and manufacturing section. So this would be, we always talk about with POE is we ramp up to get to trust calcs, and then we kind of start to head back down. Students tend to like this unit because it's not as much math initially. It gives them some other things to do. They can take a break from math, if you will, until they eventually get back into and we do some material testing. So I only have 5 minutes or so here, so I'll just kind of get you into the beginning of this, and then we'll pick up again after a break. We'll send out that email, obviously, with the invite as far as which day we'll start, which probably, it'll be the 5th, January the 5th. So in unit, or lesson 2.2, the students, we talk about in Unit 2 is the students first learn about structures, strength of shape, strength of design, how they adjust something with the design that's going to make the structure stronger and use less material. And we don't really, I mean, we do a little bit, but we don't really ever talk about really the makeup of the materials and why we select certain materials over other materials. So this is when we start to get into that, okay, this is why we select these materials. This is how we classify materials. And this is where you really get into the chemical science, or the chemistry, if you will, some chemical engineers type of stuff. It starts off with an introduction to materials PowerPoint, which isn't a very long PowerPoint, and it's not a super, I wouldn't call it a super descriptive PowerPoint, but it gets them into looking at materials and how we classify them into different groups and why we classify them into different groups. So we're looking at physical, chemical, thermal properties, and how we kind of fit them in each one. So, and you can go through this, I'll just kind of click through a little bit of it right now. One of the things that I like to use is this website called MatWeb, and they have thousands and thousands of different materials that have been posted on there, and the materials will give you a description of what the material is used for, but it'll also give you a description of the different properties that we'll eventually start to talk about and go over. Then they talk about, materials are so important that in history we actually classify periods of time based off of history, the Stone Age and the Bronze Age. And then we kind of go through discussions and talk about, well, why did they stop using stones? Why did we start using something else? Was it because stones became obsolete? Was it because we no longer had stones around? But we kind of talk about this, technology, science, and materials. And as we improve one, we discover one, we fix one, the other ones are able to also improve based off of what we've done in the other categories. So this one ends up being a pretty good discussion for us. We go through the different things. And I think for most students, they've had this. They've talked about this, in most of their science courses and through middle school. They've kind of talked about a lot of these different things. So it's more of like a review discussion as we go through, and just kind of classifying it, why they fit into these different categories. I like to bring up examples of things that I have around the room or things that I have, like a boat, like a carbon fiberglass water ski, or, why do we have these different materials that we've used. So they go through this presentation, which doesn't take too long. And then what they're actually challenged with doing here is, what I have them do next is I have them go through and do a presentation on a specific material. So they go out to MatWeb or to another website, and they have to choose a material, and every student has a different material, and they have to go through and create a presentation, find different information. So one of the things I want to know is, first off, what the material is. Where do we get it? Where does it come from? Is this something that we have to mine? Is this something that we're getting from another product? So you have to do a little bit of research. What is it used for? Coming up with major uses. What's nice here is they get to look at, like, this student chose carbon graphite. Pencils, I think, was a pretty easy one for most students, but maybe they didn't know that it was in batteries or in steel making. So they got to extend their knowledge of where these materials are used. I also have them take two different materials, but that they're similar materials. So if we were doing, let's say aluminum was the material we were doing here, maybe I would compare that against copper. They're both metals. They're both used for conducting, whether it's conducting, thermal energy or electrical energy. They're both used for kind of similar things, but what makes them different? So they go through that website, MatWeb, and they compare things like density, modulus elasticity, which is something that they came up with, or that we started using in 2.1. The thing that we didn't really get into is, the different terms. So we kind of talk about what a gigapascal is and how that relates to, what we read out is pounds per square inch. And then we get into bringing it back to our electricity unit. Students can see here that this material has a very low amount of resistance. We get into our thermal stuff, go back to 1.3 now. We're bringing back out specific heat capacity. So they're able to then connect these things that we've learned up to this point and be able to apply it to this new material that they came up with. Oops. So then I like to also talk about what are the dangers of these different materials. And for some of the materials, it's very difficult to find the danger. It's very obvious to say if you have uranium or something like that, where just sitting next to you is actually dangerous. But how is carbon graphite something that could be dangerous? So they have to go out there and figure out research. Is it the actual material, or does it come down to the process to make the material, the process to mine the material? What is it that can actually be harmful to us? With most materials, we're worried about how does it break down. And it could be natural decay, it could be decay from other things, other interactions. Maybe we're using the carbon graphite in a bearing. So how does that material break down? Why is it not always there? Why does the bearing eventually fail? So how can we, what's happening in there? And then in the end, is it possible to recycle this? If it is, how do we recycle it? How do we use it? So it's just kind of the process that we use then to get them into the material research. All right, so 8 o'clock, that's kind of the beginning. When we get back on January 5th, We'll continue forward here. We'll obviously answer any questions that you have. If you have questions from Unit 1 or beginning Unit 2 still, let us know. We'll help you out the best we can. And we'll pick up from here and we'll move on. If you don't have any questions, have a Merry Christmas, and we'll see you back here in a little bit.
Thank you very much. Merry Christmas.
Hey, Adam, can I ask a couple of questions?
Go for it.
Okay, I'm sorry to keep you.
No worries.
So over Christmas break, I'd really like to try to get myself as caught up as possible.
Okay.
Just because we have the time off. Did I hear right that all of the previous lessons that you guys have done, like this whole video conference, is on the My Project Lead the Way course?
Correct, yeah. If you go to our
Can you help me
cohort
find
page,
that? Okay, I'm there.
are you still seeing my screen, hopefully?
No, I can look. I'm there now. Go ahead.
Okay. On that,
Oh, I see ya. Okay.
yeah, when you scroll down on that page, you have to go down
Yes.
about halfway, and it says LOL. It's not laughing out loud, but it's live online session recordings.
Okay. Oh,
And
great. That looks good.
yeah, tonight was actually the 7th meeting that we've had. Now,
Okay.
the odd thing about these videos are if we don't have our screen showing, it just shows up black, but you
Yeah.
hear our voices. So a
Okay,
lot of times
that's fine.
it'll be on and off.
Okay. Can I ask too, like whenever, because you said you run on block scheduling, is that correct?
Yes, correct.
Okay. So do you typically just introduce the PowerPoint, and then I saw there's a lot of other papers associated with each lesson. Do you just kind of like hand those papers out and go through them one by one after the PowerPoint? Do you do that before or?
Yeah, it's kind of, the hardest part is the first time you go through, because you have to figure out which ones are good and which ones are bad. Not necessarily bad, but like which ones you want to use. Sometimes they give
Yeah.
activities that you could easily say, oh, I'm not going to do this one because I can do the content this way.
Okay.
Typically, what I'll do is I'll introduce the presentation or some of the presentation, and then have the students work on the activity or project. Depending on the PowerPoint, some of them are lengthy. So maybe you do a little bit today, you do a little bit tomorrow, but you have them start on the activity so you can kind of break it up. But if you just PowerPoint them for an hour and a half, they're going to hate it. So you have to watch.
Yeah.
You don't PowerPoint them to death.
Okay.
But I mean, those are like, you're starting again in January, right? For your first.
Yeah, like at the end of January, January 25th, I think, January 25th, 26th.
Okay, that's right about the same time that I switch. I have a second semester. I'll have another POE in the second semester.
Okay.
My first week is typically getting them into the LMS so that they know where all that stuff is. Teaching them the engineer's notebook, they start their portfolio. They start their digital portfolio using PowerPoint. The first week isn't real. It's a lot of getting rid of some paperwork things, if you will.
Okay.
And then we'll start in.
Is there a place somewhere where like I can make my own quizzes and stuff, but like is there somewhere where I can get them? Because I think that there was somebody who was supposed to teach this class, and he went to the summer training, so he knows all about it, and he tried his best to tell me, but he got hired at another school district. But so is there like a pool of quizzes and tests that people have made? He tried to kind of explain that to me because we saw a few here and there, but
I know that there have been some groups that have kind of gotten together to share tests back and forth or questions back and forth, but officially there's not like a location you go to for all the quizzes.
Okay.
Most of those ones are, each of us create. Now, Project Lead the Way has released some of the final questions from, past whatever years, and, they'll send you an email, and they basically push those questions to your, whatever POE class that there is. You'll see that there's a couple of questions that are in there.
Okay.
I will also, I'm sorry, I stayed.
Oh, sure, no, go ahead.
And I really wanted to hear your questions, but I also found out late that, so I've been going into the modules file to pick up all the resources, but there is a files section, and in the files section, there are both teacher resources and student resources. And so I don't know if I saw any quizzes in the files resources, but I at least found answer keys.
Oh, that's
Because
great.
like the first like 3 months, I didn't have a single answer key, and I was like working the problems, and I'd have my husband check my work, and then I'd do them in front of. I mean, it was just terrible. And then I found
Yeah.
out that they actually had in that TV or in that file section
Mhm.
under teacher resources, there were a lot of answer keys that that caused me so
Yeah.
much anxiety not
Really
having it.
helpful.
Yeah,
So,
but
Now I don't see that listed in my courses at all. Will I not get that probably until January?
you don't have this one right here.
No.
If you're a registered teacher, which you just are, but you were
Uh-huh.
just added, so it's possible maybe they're not quite on
Yeah.
any. You should have access to it already. When did
Okay.
I mean you just got added? But was that like a week or two ago that you also like signed up or got enrolled?
Yeah. Yeah, about a week or two. I don't know, my boss did it, so he kind of told me, he's like, "Hey, it's official." So,
Yay,
I
high
know.
five.
Yeah, thank you.
I have. Go ahead.
I was going to say, if you don't see it in the next couple of days, I would email school support at projectleadtheway.org.
I sure will. I'm sorry, can you say that again? Who should I email?
School support. Here, I'll type it over here.
Okay, thank you.
pltw.org.
Great.
Yeah, school support. And they're usually really
Okay,
good
I'll
with
copy
getting
that.
you access and figuring out where, what needs to happen.
Oh, that's great. And then my kids will have it. My kids should have a login eventually as well, right?
Correct. You'll have to
Okay.
load your students though. So,
Oh, I will. Okay.
well, it all depends on who the administrator on the account is.
Yeah.
So
Okay.
if you're that person, then there's an Excel file that you'll go through that process to load. If it's your principal or somebody else, then they'll be
Okay.
the one that's responsible for doing that.
Well, we have we have the IOD or whatever it is, so somebody has to know how to do it at our school district because the kids are enrolled there.
yeah, IED.
Yeah.
Yeah. So if they are
Okay.
if they are in order to take the final, they have to be enrolled in the LMS, but not everybody's using
Okay.
the LMS to offer instruction to the students.
Okay. Is that how you do everything?
I do a little bit of both. I have a website at school that I have to have, so I use that, and then I also
Okay.
I use the quizzing feature for the LMS in order to assess or allow the students to review stuff.
Okay. I think that's probably. I'll stop bothering you. I might send you a couple emails over break or whenever if you don't
Yeah,
mind. But I
yeah,
appreciate all of your time and your help, and
yeah, no
I
problem.
think I'm getting there, so I appreciate it.
You're not
So,
bothering me at all.
Adam, I did have a look ahead question. So I think
Okay.
in the next unit we're going to begin programming, aren't we?
In Unit
What
3.
is our language and what are we programming? Do we have a robot?
Yeah, what we're doing is something called natural language, which is something that Carnegie Mellon and Robot C got together with, and they kind of created. We're programming our Cortex and using the VEX equipment.
So say that again. We're programming our
The Cortex is that little gray box that you have with your VEX stuff.
Okay. So I have Fisher Tech, so I don't know what I have.
So then, yeah, you won't have the Cortex then.
So I won't have a Cortex. Okay.
You'll use
All right.
with the Fisher stuff, depending on which version you have of it, you'll have some sort of PLC that they either call the TX. Do you know what they look like? Do you have a little black box or is it like a clear one?
I have a little black thing called a robo controller.
Yeah, so you have the little black thing is a TX controller.
Okay.
And that one is the latest version. And you won't use Robot C, but you'll use a program called Robo Pro.
RoboPro, yeah, so that's loaded onto my computer, a RoboPro.
Right.
And so does that actually have a robot? Because a kid was telling me today that all they did was light up things and
yeah,
they put on lights and off lights.
Well,
I'm just trying to get ahead a little bit.
Okay. What happens with that is the students will go through activities 3.1 through 3.17, and it'll step them through, the basics of RoboPro, how to use it, what the difference is between, these different blocks that they're using and the different functions and how to use all the different things. And then eventually when they get to 3.17, that's when they then like, all right, you have to build an elevator or something like that. So they have to, instead of following instructions, now they're building something on their own and programming it.
Okay.
So there's no like already pre-built robot, but there's pieces and then they make the thing. At the end of Unit 3 is their design problem. It's what's called a material sorter. So they design this trash sorter essentially that has to sort out different color, different material marbles.
Okay. And so there must be a light sensor then.
Correct, yeah.
Okay. So what would you recommend to do to kind of get ready? Just pull down all of those things and look through them and see if I can find the pieces that are associated with that?
Yeah, I mean, I don't know how well the Fisher was stored, but one of my problems is always that stuff is just horribly all over the place. So I, came up with a really good system to make sure everything was stored properly so kids can get to it quickly. And then to get prepared, I would just go through the activities that they're going to go through, because it really gets you into exactly what they're going to do. And then when they have questions, oh yeah, I did that, type of thing.
Yeah. Yeah. And then, okay. So I actually have fairly good organization. That was one of the things I inherited, is actually a very nice system. So I have lights and I have things like that. My problem is I don't know what stuff is. So I've identified a lot of stuff. There's a bunch of other stuff that that's why I keep my favorite question is, what does it look like? If you tell me what it looks like, I can see if I have it. And if not, then I'm kind of not knowing. All right.
Yeah.
I'm sorry. I know it's late there on the East Coast, but
No
I
worries.
appreciate that.
I don't have a life, so it's okay. With the Fisher Technics stuff, one of the hardest parts about this is they must have given you like 200 different pieces, not quantity, but just different pieces. So you'll find out, oh, you need a strut. Well, what length strut? What size strut? Type of thing. And eventually you start to get the lingo with it. But the really important pieces are just the different sensors and motors that you'll have.
I'm kind of making I'm making it work this year and trying to make a plan for what I want to do for next year. So people have recommended that I just get them back. So I wish you good luck, the new teacher. I don't know if she's still here, but I can commiserate. Thank you.
Yeah.
All right. Thank you, Adam. I
Good luck.
appreciate your staying late.
No problem.
Bye-bye.
See ya.
Thank you.
Have a good one.
Thank you.